Right. Okay, for this particular question, the spectator is going to be this point here. Okay, so from this corner here, you're going to measure down 52 millimeters, and from this corner here, you're going to come in 92 millimeters. That'll give us a point that's going to be where our spectator point's going to be. Okay, so from this corner, I'm just going to draw a light straight line down like that. I'm going to measure down from this corner 52 millimeters, which is going to be there. Okay, then I'm going to extend this line down and extend the line through the 52 here, and I'm going to measure out here 92 it was. That's my location for the spectator. Okay, so just put S there. That is the spectator point. Okay, now if you don't have exactly the same measurements as me, it's okay for today. But from here down, it should be 52 millimeters, and from here to the actual spectator, it should be 92 millimeters. Again, if you don't have exactly them measurements, it's okay for today. As long as you have a spectator point at least down here somewhere, you'll be able to complete the question. But if it's not exactly the same as mine, your 3D will look a little bit different at the end. Okay, so just be aware of that. Okay, so we have our spectator point. The other thing we were told is we need to find, so basically, I'll write a few points down here at the side. The first step, if you like, is going to be to draw the plan and elevation. Okay, or whatever you're given. Second point is to locate the spectator point, which we've done there. The next point, or the third point now, is going to be to locate our picture plane. Okay, so the next thing is to locate our picture plane. I told you before, in this particular question, the picture plane is going to pass through the point that's closest to the spectator. Now, when we're drawing a perspective drawing, we use our plan. You will always use a plan to draw your perspective drawing. The only reason we need the elevation is we need it for heights later. Okay? So the elevation now, forget about the elevation now. We're just dealing with the plan. Okay? The point closest to the spectator is this point here. I'm going to just call it corner A just so you can see it. Okay? So I know the picture plane passes through that. I have no idea what angle it is. Okay? To locate the picture plane, you want to basically join the two furthest points to your right and left. So if this is you standing here at the spectator point and you're looking at this object, the two furthest points at the end of your cone of vision, if you like, that you will see on both sides is these 2 points here. So you join them back to the spectator, which makes your cone of vision looking at that object. Okay? So I'm going to do that now. I'm just going to join the 2 outside points here to my spectator, like that, and like that. If you like, we've created a cone of vision. That's, if I have that real object in front of me, that's what I see. That's the 2 furthest points I see on either side. Okay? What we need to do, you'll always do this to get the picture plane. You'll join the 2 outside points, the furthest outside points to the spectator. The second step is to bisect this angle. Okay, so we'll bisect the angle now. So get a compass, set it to any length, put the point at the spectator, and just draw a semicircle or an arc. You can do an arc that crosses both these points if you want, or you can do what I done, just do a full arc. Using the same length, so don't change your compass, the same length. You put the point of your compass on both sides, and you want to create 2 arcs where you basically get an X. Okay, that means we've bisected this angle. So for example, if this angle was 50 degrees, we've bisected it, we've got a point here with the 2 arcs across. That's basically half on that 50-degree angle into 225 degrees. Okay, so guys, this is going back to first year TG. Okay, so then draw or join that point back to your spectator. Okay, so you join that point back to your spectator and you're halving the angle. Okay. The third and final steps then of this process of getting the picture plane, this will always be the same method, is to draw our picture plane. Our picture plane now will be 90 degrees to this bisector line we've got, plus we're told in this particular question it actually goes through corner that I've labelled A here. Okay. So to do that, line up your set square with your bisector line and get the point to go through corner A. Okay, so I've lined it up here with the bisector line, and it's on the other side then is going through corner A. What I can do then is just draw a line going across there, and I need to extend it then on down here. So I've got this line now. This is my picture plane. It's going through corner A, and it's at 90 degrees to the bisector line. What I'll do is I'll draw it in a different colour here. So I have a green marker here, just so you can see it better on your screen. That is your picture plane. So I'm just going to label that PP for picture plane. Okay. So again, to locate the picture plane, step 1, join two outside points, whichever they are. Join the two outside points to the spectator. I'm just going to write S for the spectator, or I'll write SP for spectator point. The second step then is to bisect the angle. Again, that's first year TG. And the final one is to draw PP as picture plane at 90 degrees to the bisector angle. And you should be writing this down, guys. Okay, this is the same setup for every question. Okay, step 1, we drew the plan elevation. Step 2, we found our spectator using the measurements we were given. Step 3, we had to draw the picture plane. It's always the same steps to get the picture plane. Join the two outside points. In this case it was these 2 points. Join them back to the spectator. Bisect that angle using your compass, and then you draw your picture plane at 90 degrees to your bisector line. Okay. Now, so that's some of that question set up. Okay. So that's what the 3D stuff I was showing you in the PowerPoint. This is what it looks like in your drawing in 2D, and this is the way you'll always draw. Okay, obviously you'll have different questions. Now, there's 2 other points we need to draw before we start drawing our 3D, and that's to find our ground line and our horizon line. Okay, now your ground line, so locate, step 4 is to locate the ground line and then also locate the horizon line. Okay. They will always be parallel to your picture plane. Okay, so the ground line, horizon line are always going to be at the same angle as the picture plane, because the ground line is at the bottom of the picture plane and the horizon line is your eye level. Okay. You'll be given an eye level or a height for the horizon line for every question. Okay. Now what I'm going to do is I'm going to draw them down here. You could draw, technically you can draw them anywhere as long as they're at the same angle as your picture plane. I'm going to draw them down here because I have space, so I won't be drawing the 3D on top of that. You can draw them at the top, you can draw them at the bottom, you could even draw them right here, but it would be very, very messy. Okay. So I recommend you just do it the same way I'm doing it. To get your sliding set squares, or if you have an adjustable you can use it to set them up. So set up one of your set squares in line with the picture plane, set the other one to the side then, if you don't have your adjustable. What you're going to do is slide a line down. So I'm going to Now for this question, the horizon line is 50 millimeters above the ground line, so I'm going to draw my line here for the ground line, so I have enough space to at least come up 50 millimeters here. Okay. So I'm going to draw it here. Alright, so here I have my ground line. Okay, and I'm going to label that GL for ground line, or you can write ground line, whatever you want. So for this particular question, the horizon line is going to be 50 millimeters above the ground line. So all you have to do is come up 50 millimeters from the ground line and draw another line for the horizon line that's parallel to the ground line in the picture plane. And what I'm going to do is come up 50 in two spots so I can just join them together, and it'll be parallel, just to speed it up for me because I don't have the adjustable on me today. Okay. So then that is my HL is for horizon line. So PP is picture plane, HL horizon line, GL is ground line, and S or SP is the spectator point. Okay. Now, the fifth step, setting up perspective question, is to find our vanishing points. Okay. Now, technically we've already got our vanishing points. Okay. See these 2 points here? Okay, were our cone of vision, if you like. So the 2 outside points of the plan go back to the spectator. Them 2 points there that cross the picture plane are basically our vanishing points. Okay. So what I'm going to do is I'm just going to highlight them in 2 dots here along the picture plane. And what we do is we take them lines down at 90 degrees to the picture plane till they meet the horizon line. Okay, they need to meet our eye level. Okay, so remember, horizon line is eye level. Alright, so just at 90 degrees, so nice and simply just line up a set square. Take your line down like that. So that is, I'm going to call VP1, vanishing point 1. And for the other one then, it's going to be here. So you'll always have 2 vanishing points for higher or ordinary level questions. Okay. There is a thing called 1 point perspective, but we're not going to go over that. So it's not going to come up. Okay. VP2 is vanishing point 2. Okay. So step 5 is to locate the 2 vanishing points. Okay. So you locate your 2 vanishing points just by getting the points that cross from your cone of vision, the 2 points that cross your picture plane, take them down at 90 degrees to your eye level or height line or horizon line. Okay. And now we're ready to start drawing the 3D object. Okay. So start drawing your 3D object. Every point in plan needs to join the spectator. In other words, every point or corner needs to go back to your eye line. Okay? So as you can see, there's 1, 2, 3, 4, 5 points there that need to go back to the spectator point. So we're going to join them back now. Okay? So every point, join it back to the spectator. Obviously, A there, corner A is going to be on our picture plane. We'll join them all back. Okay, so there's 1, 2, 3, 4, 5, 6, 7 points. Okay, we already had these 2 points joined to the spectator. You join all the rest back to the spectator. Okay. Now, where all them points cross, let's get a different colour here. Where all them points cross the picture plane is points that we need. So I'm going to highlight them. Okay. They're all points that we need. Obviously corner A is there now. Alright. So I've just highlighted all them points crossing there. Where them points cross the picture plane, similar to finding our 2 vanishing points, we take them down at 90 degrees into where our perspective or 3D drawing is going to be. Okay. Now, our vanishing points need to be out wider because our cone of vision is a lot wider than this. Okay. So to finish, before we start drawing our 3D or taking these points down, our two vanishing points need to be pushed out wide. Okay. So from the spectator point here, you're going to make a 90-degree angle. In other words, you're going to draw a straight line out here to touch the picture plane and a straight line up to touch the picture plane. So I'm going to do it in yellow here. So from the spectator, just draw a straight line up to meet the picture plane, and then draw a straight one out to your left here to meet the picture plane. That will give you a point here and a point there. Okay. Where we have them 2 points, again, like what we done to here, we're going to take them points down at 90 degrees. Okay. So we're just going to take them down at 90 degrees to our ground line or our eye level. Okay. So that is going to be vanishing point 1. And then this one, I'm going to take it down. That is going to be vanishing point 2. Okay. So to locate now, so these two, I'm just going to rub them out for now. Don't really need them in this question. Okay. So VP1 and VP2. So we finished locating our vanishing points. Okay. So what we've done is we've basically made a 90-degree angle at the spectator point. Okay, in other words, they're my yellow lines. Okay. Where these points cross the picture plane, PP, it basically gives us our 2 vanishing points. Okay. So it gives us our 2 vanishing points. We then just take them down here at 90 degrees like that. Okay. Remember, vanishing points will always be on the HL or horizon line. Okay. So vanishing points will always be on the horizon line. Next thing we need to do is just to take all these points down at that angle. Okay, so I'm going to take corner A down because I know it's on the picture plane. Just take it down at 90 degrees. Gives me a point here. Okay, so I'll just highlight that as A because I have it highlighted up there. What I can do then is join A to VP2 and VP1. Okay. The overall height of this object was 35, so I want you to then measure up here from A at the ground line up 35. It gives me a point here. Okay, and I'm going to join that point to VP2 and VP1. Okay, and you can now see the 3D object or the perspective drawn is going to be drawn in here. Alright, it's going to end up being drawn in here. So at this stage what I can do is take my points here to cross the picture plane all down. Okay, so we'll just extend them all down. So I'm going to extend the 2 outside ones first. Now they're going to be in here, so I'll actually highlight that. So when you take them down, that'll be a dark line in there. Okay, and when I take this point down here, sorry, this one here, again at 90 degrees to the picture plane, it's going to be in here somewhere. Now I'm not going to draw that in dark because I know looking at this that is not the full height. So I'm just going to draw it in lightly here. Okay. And what I can do then is just darken that line in. I can darken this line in here as well. So guys, we're nearly done. We'll be done now in 2 minutes. The height here of this part was 20, so I'm going to measure up there 20. Gives me that point. Again, I'm going to join that 20 point to VP2 and VP1. Okay. Then I know that the height of this corner, if you look back to your drawing, goes to there. Okay, that point goes to there. Okay, so these are the front corners. So you need to kind of visualize your object then, using your plan and elevation. Sometimes you'll actually be given a 3D in the exam, if you're lucky. Okay, so you have that height. Now what I need to do is take this corner here down, which passes the picture plane here. So take it down at 90 degrees. Gives me this point here, so I know that that joins like that. I'll do it very quickly. I'm aware now that if you have class next, we're running out of time here. Extend that line over there. Extend that line here. Okay, so that is this side of the object done. That's this side kind of done. What I need to do now is join these 2 points back to VP2 to kind of get the surface. So every point basically in your perspective has to go to your vanishing points. Okay, you can see then they cross here. Alright, so they're going to cross there. So you can just darken that in. This point then actually, I'll darken these in first so you can see them. That point there. So every point goes to the vanishing points. Okay, that's why we're getting this perspective view. This point now needs to go to VP1 to finish off that side. Yeah, needs to go to VP1. Okay, so it's coming up there. So you know there's a little kind of area here, so that's why they don't meet there. And then just to finish off this top surface, this point goes to VP1 and that point will go to VP2. And that'll finish off the surface. Now I know we kind of had to rush through it here a wee bit at the end, but I'll put this video up for you to have a look at. Okay. Right. Like that. Okay, so that's their 3D object completed. Okay, that's our perspective drawn of this object done. Okay, so you end up with a 3D object. And obviously it depends where the spectator point is for how big and what kind of angle we're looking at the object. Alright.